students, a warm good evening to all of you. So now today in this session we are going to see all the important concepts that are related to coordinate geometry. So as usual I have given detailed conceptual notes along with some important models of the questions that I would have solved, and I would have given you a lot of tricks also. And lastly, I would have given you the important numericals that are very important for the examination point of view. So guys, if you have any doubts in this chapter and also in the previous chapters, so you can feel free to book a class, and I have given my WhatsApp number in the description box. You can contact me there, and let's have a very great time together. So now let's go into the session. Let's collectively rock and roll. Thank you. Hello guys, very good evening to you all. So in this today we are going to see coordinate geometry. From ninth grade itself you would have been studying what is coordinate geometry. That is a set of ordered pairs which is x and y coordinates, which is used to be plotted in a graph. So we are going to study what are all the topics and what are the concepts in detail along with important numericals, problem solving tricks and everything. So introduction. So for that, simply I already told you, so the collection of x and y coordinates that can be represented in a graph. So x comma y, x coordinate here is otherwise called abscissa, and y coordinate here is otherwise called ordinate. So you just have to know the various quadrants. This also you would have studied in your ninth grade. So if both x-axis and y-axis are positive, so then it will be lying in the first quadrant. If x is negative and y is positive, then it will be in the second quadrant. If both are negative, then it will be in the third quadrant. Then if x is positive and y is negative, then it will be lying in the fourth quadrant. So these are the various study of quadrants, and after that comes distance formula along with some of the important applications, and section formula along with its applications. So this is about the gist of the chapter. Now we'll go to the chapter detailed conceptual notes. So distance formula, see here, A has coordinates of x1 and y1, B has coordinates of x2 and y2. So the distance between A and B, that is AB, that is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. You can also write it as x1 minus x2 whole square plus y1 minus y2 whole square. That is also correct. So conventionally we use this. So point on the x-axis, any point on the x-axis, you have y coordinate as 0. So that is this is a point. So x comma 0 means it is lying on the x-axis. That is the implication. And similarly, any point on the y-axis, your x coordinate will be 0. So 0 comma y. So now after that, distance of x comma y from the origin is 0 comma 0. So distance between x comma y and 0 comma 0, if you apply this formula, you will be getting this value, root of x square plus y square. And after that, equidistant. So these are some special cases under distance formula. So equidistant means equal distance. So this point P has equal distances from A and B. So that is PA is equal to PB. We already saw from the distance formula that the distance is in square root. So to express it in a proper equation format, we just have to square it. So PA is equal to PB. That is the purpose of squaring. So if PA is equal to PB, then PA square will be equal to PB square, and then we have to apply the distance formula, and then by squaring it and then simplifying, you will be getting the answer. So special case, I have written this as one example. Point on the x-axis which is equidistant from minus 3 comma 4 and 2 comma 5. That's, they will be asking this as a question. So for this I have just given you the hint how to solve. P here, since it lies on the x-axis, we already saw any point lying on the x-axis is x comma 0, and A is minus 3 comma 4 and B is 2 comma 5. So this is given as equidistant. So PA equal to PB, so which implies PA square equal to PB square, and then you have to proceed the usual way. But the point P here should be taken as x comma 0 since it is lying on the x-axis. Similarly, if I change this to any point on the y-axis, then we can see how this value changes. So P should be now written as 0 comma y because it is lying in the y-axis, point on the y-axis equidistant from, and remaining things are all same. A is minus 3 comma 4 and B is 2 comma 5, and then you just have to square, you just have to equate both PA and as well as PB, and then square it, and then if you simplify it, you will get the answer. So we'll see the what are the types, special types of quadrilaterals, which is square, rhombus, rectangle, and parallelogram. So a quadrilateral, as you all know, it is a four-sided figure. So for a given quadrilateral to be a square, all the sides should be equal. All the sides should be equal and also along with the diagonals. So if everything is equal, then you call it as a square. And if all the four sides are equal, but the diagonals are not equal, then that means it is a rhombus. For rectangle, the opposite sides should be equal. That is, AB is equal to CD, and also AD equal to BC, and also the diagonals should be equal. AC is equal to BD, and also the diagonals bisect each other. So diagonals bisect each other means midpoint of AC should be equal to midpoint of BD. So for parallelogram, so see, square and rhombus have one pair, because for square and rhombus you can easily identify the difference. The diagonals are equal in square, but in rhombus the diagonals are not equal. For rectangle the diagonals are equal. Similarly in parallelogram the diagonals will not be equal. So parallelogram, opposite sides are equal just like a rectangle, but diagonals are not equal, but they bisect each other. So these are the various types of quadrilaterals. I hope that you guys are able to understand completely the entire first topic, which is distance formula. Now we go to the second topic, which is section formula. It is a very simple topic. So here line segment AB is given where A's coordinate is x1 and y1 and B's coordinate is x2 and y2. Suppose this point P divides the line segment. We don't know the ratio. Suppose we don't know the ratio, that is why I have kept it as M and N. The point P divides internally the line segment AB in the ratio M is to N. Now we are going to see what are the coordinates of point P. So point P's coordinate is, this is a proper section formula, mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. Suppose if m is equal to n, that is, it divides equally. It divides equally in such a way that PA is equal to PB, that means the ratios are equal. Then that means if you substitute M and N, both of them are equal, then you will be getting x1 plus x2 by 2, comma y1 plus y2 by 2, which is nothing but the midpoint formula. So for midpoint formula, this is how it is being derived. Okay. Now next case is special case. Find the ratio in which the line segment joining 3 comma minus 6 and 5 comma 3 is divided by the x-axis. These are very important questions under section formula, so that's why I have chosen it and I have solved this also. So let the ratio. So suppose if they are asking you to find the ratio, first draw the diagram so that it will be very simple for you to represent. P 3 comma minus 6 is given, Q 5 comma 3 is given. We take R. They have given it divided by the x-axis. So any point on the x-axis, you know x comma 0, and ratio is k is to 1. So this is x1 y1, this is x2 y2, and this is m and n. M is k, n is 1. So we apply the section formula mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. So this r is x comma 0. So that is nothing but 5k plus 3, because m x2. So 5k plus 3 divided by k plus 1, comma 3k minus 6 divided by k plus 1. So here what we have to do after writing this is, we just have to equate the y coordinate here, because y coordinate is 0. So if you equate the y coordinate, it will be very easy for you to find the value of k. So by equating the y coordinate straight away and cross multiplying, I'll be getting 3k is 6, which is k is equal to 2. So I can substitute it here. So the ratio is k is to 1. Suppose in your question they may be asking you to find the coordinates of the point of division also. If they are asking you that also, you need to know the x coordinate. For that I am equating this. X is equal to 5k plus 3 divided by k plus 1. So here I am substituting k as 2. So I will be getting 13 by 3. So the coordinates of this point of division are nothing but 13 by 3 comma 0. So that is the point R. Point R's value is 13 by 3 comma 0. I'll change the question slightly and I'll write the same values, but instead of dividing it by x-axis, I'll write dividing it by y-axis. So let the ratio be k is to 1. x1, y1, x2, y2 values I have written, m and n values are written. Instead of x comma 0, I have to take 0 comma y, this dividing into the y-axis. So I am applying the section formula same way, but now instead of equating the y coordinate, we have to equate the x coordinate, because here it is 0. So 5k plus 3 by k plus 1 is equal to 0. So that means I will be getting on cross multiplication 5k plus 3 is 0. So k is equal to minus 3 by 5. It's very rare. The value of k comes in negative. That's very, very rare. So they may not be asking you such negative value questions. But yeah, so for p, similarly equate the y coordinate, substitute the value of k here. Y is equal to 3k minus 6 by k plus 1. And here you just have to substitute k's value as minus 3 by 5. So if you substitute 3 into minus 3 by 5 will give me minus 9 by 5 minus 6. And after that I am taking the LCM. So I will be getting minus 39 by 5. Denominator 1 minus 3 by 5, that will give you 2 by 5. 5 and 5 will get cancelled. So I will be getting the value minus 39 by 2. So the coordinates of point R are 0, minus 39 by 2. And next is important case is trisection. Trisection means it is divided into 3 equal parts. So A, B, P and Q. P and Q, both of them divide A and B, but we just have to find the ratio. So P divides AB internally in the ratio 1:2. See here, 1:2. PA is one part and PQ and QB are two parts. So P divides AB internally in the ratio 1:2. Similarly, Q divides AB internally in the ratio 2:1, because AP and PQ are one part and QB is separate part. So that is why Q divides AB internally in the ratio 2:1. With this, the chapter is over and I have given you the important questions. All these questions are taken from the new edition of the textbook. So guys, if you have any doubts, you feel free to contact me. I have given you my number in the description box. So all the very best guys. We will upload new chapters the subsequent days to come. Thank you.